Hi, welcome back. This is Raju from Smart AI Technologies. Today we will be working on detecting objects using YOLO for part 2. In part 1, I think you saw like we built a proper data set that we can feed to our YOLO V4 model. If you missed that, you can visit to the given link below and you can see that video first and then come here. Okay, once you create your own custom dataset using the tool and the source I provided previous video, then this video will be very helpful. Here what I am going to do is, now I am going to import that dataset whatever we created there, and then I'm going to build that YOLO V4 model and we'll get the result. So let us start with the work now. First, I'm using Google Drive as a data storage. So here I'm creating a new folder called YOLO for demo. So now here I am going to upload my data set, that is custom data set which we created. I think you maybe named it as OBJR like that. Rename it as a custom underscore objects. Okay, it will be very good. Now here accept classes.txt. Okay, except classes.txt, all the things are our main data set. Okay, I think you are ready with the data set. Now we can move forward by building the YOLO V4 and testing the YOLO V4. Okay, then fine. I have this Jupyter notebook. I will be sharing it with you. Okay, you can message me, otherwise I will help you with this code. Okay, I will be opening it with Google Collaboratory. And I will be referencing main darknet from GitHub. Okay. Alexi AB darknet. Yeah, this is the main source of YOLO info model that we are using now. So whatever the commands we use, they are all provided by this repo, but it will be somewhat confusing for you if you try to go through it. So I thought like I should give you a step-by-step guidance for that. Okay. Otherwise, you can visit this for YOLO info. Okay. This is somewhat confusing for you, and I think you can't go through the whole documentation at once. But what you can do now is just okay. Once you open that code, which I will provide you, first you need to mount it to the Google Drive. So I will be mounting it using this command. Give permission. And don't miss any step, then you will face some issues or some errors in the end otherwise. Okay, now I will do ls. I will enter into C drive. I will enter into CD my drive. There only will be having all the files and folders. So I will do ls. Okay, that's fine. Okay, now my folder is YOLO V4. What was that? For demo. For underscore demo. Okay. Now here what I need to do is git clone. I need to get this darknet first there. So I will take this link and I will go here and I will say git clone. So once if I run it, okay, it's cloning that darknet folder here into our Google Drive. That you will see. Okay, I will show that. Okay. Now if I open this and if I refresh it, you will see darknet folder is now available for us. Okay, now click on this darknet in your Google Drive, then wait for some. Okay, then fine. Okay, refresh it again. Create a new folder called data create. Sometimes this data folder will be already available. If it's not available, in that case we can do this stuff. Okay, and now enter into that data. Okay, now what you need to do is you need to take this away first. Class.txt, cut it. Now this is not having class.txt, but it is having all the images that we annotated using label img tool. Now take this whole folder custom dataset and paste it under data. It will take some bit time. Okay, okay, that's fine. Then what we need to do? So when you come here to darknet, here you can see under data we need to create another two files. They are like on which name we are saving this file, custom underscore dataset. Now I need to tell this model, I need to keep the information about it some way. So for that we have two files. One is dot data dot names. Two files we need to create. Okay, object dot data, for example, which I implemented already. I will show you that part. Yeah, here you can see YOLO v4. Yeah, darknet, under darknet. Okay, now as I am showing you, in my previous case it was objects. Okay, objects folder. I gave it as obj. No, so under data folder, under data folder it was obj was my data. Okay, all the images were uploaded. Then what it should have with it is, here you can see obj.names and obj.data. I should have all these two things in our case, like which I am showing you now. So what we need to do is, sometimes it will always already be available as coco.data, coco.names in our darknet folder, but in our case it's not available. So we will take it from here. In the meantime it's uploading the image data set. That's fine. And now in our downloads, see, here you can see obj.data obj. Okay, the data set is completely uploaded to the Google Drive. So we'll move to that file now. YOLO v4 for demo. Here we are coming under darknet. Okay, uh, now you see there are two data folders. So one is this which is already available, now it's completely loaded, whatever grid clone we did, and another one is this. Okay, so what we do is we will move this, actually we'll move this to that data. So under the darknet there are two data folders. So move here. Now it's moved. Okay, when you see darknet, it will take some time to load all the files and folders. That's why I was waiting for that. Now it's completely uploaded. When you see that data folder, this we don't need now, which we created manually, so we should wait for some time. Okay, let us delete this. Okay, there is already data folder here. Okay, under which we have our custom underscore dataset that contains all the images now of both the classes. One is Apu and another one is Steve Jobs. Okay, then it's fine. Now as I mentioned, I need to have I will already be having coco.data and coco.names, but here I should change them according to my requirement. First we'll see what is this coco.names. Okay, if we'll open with editor coco.names, I will open with some editor. Even some commands will be available here and some steps will be available here in this uh, alexi.ab.net, but I think it will be somewhat hard for you to go through it. Okay, you can follow this video completely, you will be getting it, okay, without any problem. Here you can see under this whatever the coco.names, it will be having all the number of classes that the YOLO v4 model is actually trained for. But in our case we don't want all of this, we just want second one is Steve. Sorry. Okay, like this. And also we don't want it as a coco.names. What we want it as, you need to see the file name custom underscore dataset. So you should name it as custom underscore dataset dot names. Okay, then save it. Okay, this is done. Now here I should have coco.data. I should have that, but I am unable to see that here. Okay, then we need to upload it from outside. Sometimes it will be there, sometimes it won't. Then we need to create or we need to upload. In our case, I will upload this obj.data. Okay, it's uploaded here. Let's open it. Yeah, you need to have patience, and when you are using this Google Colab, it will take some time for loading and all those stuffs, and you need to have some external tools to open and edit the files. Okay. Here you can see what the information it should contain, that is object underscore data. In our case, I should rename it as custom underscore dataset dot data. So I will save it. Here what you need to mention, first you need to mention how many number of classes that we are working on, and next you need to give the path to a train.txt file. I will tell you how to create this train.txt and what information it will have, but initially give this path under data folder. We will be creating this train.txt. Okay, give that path. I will tell you what it will contain in the continuing part. So then we should give the names path. What was our file name? Custom underscore dataset dot names. Okay, and we need to have one folder for saving the trained models. You can say backup, or you can say pre-trained models are like that. Okay, in my case I am giving a backup folder, so I will be saving it. So we are done with two things now. Okay, I think it's already saved. That's fine. So let us check whether they are created or not. Custom underscore dataset dot name, custom underscore dataset dot data, custom underscore dataset. We are ready with the files. Now what we need to do is we need to come back a little bit, open CFG, and here search for control F. Okay. Search for YOLO v4 hyphen custom. Okay, here you can see YOLO v4 hyphen custom.cfg. Just duplicate it, make a copy of it. Okay, here that, and then rename it YOLO v4 and custom, okay, hyphen dem. You can say like this. Yes, remember this name. Okay, whatever you do, control C, you saying this. Now open this YOLO v4 custom hyphen dem with some editor. Here we need to change some information in the, we call this file as a hyperparameter file, where it contains hyper parameters or tuning parameters. We say we need to change according to our requirement. Okay, there will be so many variables which are already predefined, but you need to change according to your requirement. How many classes you have, how many filters you need to use for a particular number of classes, what is the max batch size, what will be the step size according to our requirement. So try to watch it clearly, and you can in the same time you can change in your files. Okay, I'll be making some changes now. Now search for the batch is 64. You can use batch 64, 32, and the more the batch size the better accuracy, but sometimes your GPU may crash when you use more batch size than this. So go with 64, and then subdivision make it 32 from 16. If this crashes your system or your GPU, then come back and make it 16 again, and then what should be the image size. In my case I am going with 416 or like that. You can use your custom size of the images, height and width. Okay, this is my custom size and taking. Okay, now we are done with batch size, subdivision and width and height of the image. Now you need to change this max batches. For max batches there is a formula which says 2000 into number of classes. That means in our case how much it will be, 2000 into 2, so it will be 4000. Is that, yeah, it is 4000. That max batches should be 4000 now. Now again, what should be the step range? Initially the step range will be very high. In our cases it should range from 80% of 4000 comma 90% of 4000. That is 3200 3600. Is that fine? If you are done with all these changes, now just to control F, search for YOLO. Okay, you will be seeing 3 YOLO layers here. So first what you need to do is go here and change this class from 80 to 2. Then filters. For filters there is a formula which says number of classes plus 5 multiplied with 3. In our case 2 plus 5, 7 into 3, 21. So number of filters should be 21. Again go for the next YOLO. Here also the same thing you need to do. Classes, just do 2 classes that we are using and filters will become 21. Again filters will be 21 and classes will be 2. So save this stuff. Yeah, we are done with it. Now what you need to do is you need to download a pre-trained weight, that is YOLO v4 dot con dot 137. Here you can see. Okay, once you click on it you will be downloading that 162 MB. Okay, that I already have with me. So now you need to go to this Google Drive, go to .NET. Okay, go to the data. Okay, now in my case go to downloads. You need to download that completely and upload. Okay, but in my case what I will do is I already have it somewhere in my other folder, so I will move it here. Okay, you should download this and you need to upload it. Okay, I already have with me this one, I think. Let me search in the downloads. YOLO. Yeah, I already have this. So what I will do now is YOLO for demo. Okay, you can check even this properties, check what is the size of that. It is 170 MB. Okay, fine. So now what I will do in this, in the darknet under the data, okay, I will try to push that here. Is that fine? And it will be uploaded within 4 minutes or 2 minutes. Okay, no problem at all. Till that is uploaded, we will see what the next part we can do. So let us move to the code part. Now here you can see you need to enter into that cd darknet. Okay, now you can see here, once if you do ls, you'll see all the folders in the darknet file. Okay, now as I mentioned you, I told you like we will create train.txt. So how we will create, and using what we are going to create that. So in my case, that the text file should have the complete path of all the images like this. You can see list of images it should have. So here I will use import globe. Okay. Next, in my case, under data I have a folder called custom underscore dataset, in which I have .jpg files. I will take all .jpg files. Okay, and then I will print out the image list. So these are all the images that I have in that file. So now what I will do is I will push them into data folder or train.txt file. I will create that file and I will push these things one by one, and I will make a text file. So here you can see, once I do this, okay, once I do this, here under data you will be able to see that train.txt train.txt is there. You open it, in the same time, okay, the thing 137 is almost uploaded. Okay, it's finishing upload. Yeah, that pre-trained weight is now uploaded, and in the same time we'll check what the train.txt now is having. Now you can see the train.txt is having complete paths of all the images within it. Okay, so then what we need to do is, okay, I made so many errors. Okay, now need to run this. Okay, directly come to this part which says SED. Okay, this is, we are setting up the GPU part, the hardware part for our requirement. So you need to run this part, and then you need to run make. If you don't run this make, you will be getting some errors which says this command is not found, or like that darknet command is not found, or like the errors you will be getting. So don't miss, try to run this. Okay, it will take us to take bit time. At the same time we'll check under data. I think we able to import that YOLO v4 dot conva 137. Okay, it's successfully imported, that's fine. In the meantime, the next command is how we will train the model. For that you need to use this command. Okay, I think you can see it very clearly. It is exclamator dot slash dot net detector train data. Under data, our data folder is custom underscore dataset dot data. Under CFG it's YOLO v4 hyphen, what we named it as uh, YOLO v4 custom underscore dataset. Is that fine? Under CFG we named it something. Let us, so under .NET cfg YOLO v4 YOLO v4 custom hyphen demo. This was our file. So custom hyphen demo. This is the CFG file that we changed according to our requirement, so that you can see. Okay, this was that file. Okay, let us, yeah, YOLO for custom.txt. This is the file. So we are giving that path. Okay. This is under CFG file. So now YOLO v4 convo 137. So here we kept it under data folder. So make it data slash YOLO v4 convo 137 don't show map. Okay. Now you need to run this. Once you run, let us see anywhere we check anything. Yeah, everything is fine. It will start to train. It will take a bit more time because it need to run for 2000 epochs. It will take a lot more time and you should wait for it. Okay, once this is completed, it will take a lot more time, nearly 8 hours, 4 or 8 hours, I think so. I'll be stopping it here. Okay, you need to wait for too long. Training started. Okay, it will take some time. The training will finish and you will get the result. Okay, I will stop it here. I will show you the demo which I already trained. Okay, once you are done with the training part, okay, once you are done with the training part, the testing is very simple. Where you need to do darknet detector, here you need to do test. If you want to apply it on video, you need to change it to demo, and after that under data you should make custom underscore dataset dot data under CFG, the same thing again, a YOLO v4 custom demo. Okay, whatever the name you give, remember it and change accordingly. And after that, once the training happens, under the backup folder there will be a trained model. There will be 4 models, so I will show you now which I already trained. Okay, so I'll go to my drive. Here you can see YOLO v4 code which I already trained. So let me show you the result now. Okay, I will go to code 2 with Google Collaboratory. Use all these files. I think till now you got all the process clearly. So if you done without any error, training will happen without any problem. Once the training will happen, you just need to do is, okay, you just need to test it. Okay, I will terminate the session, whole session. So let me connect this to Google Drive. Yeah, connect to Google Drive. Now I will enter into that C drive ls YOLO v4 code, and now Here I will directly try to see the document, and I will be skipping all these things because I already trained it. I don't need to run again train.txt thing, and I don't need to run this stuff again. But you need to remember this. You need to run it again. This make file. So now what you do is run this again. Okay. Once that make completes, don't run train part. Okay. Come here to the testing part. Okay, I will show you in my github. In the document there will be a file or a folder called backup. Here you can see, once if you are done with the training, you will be having like this uh, if like pre-trained like trained models will be saved, that we call them as weights. Okay, weights will be saved for 100 epochs. Here you can see for 2000 epoch the weight is saved, for 100th epoch the weight is saved, and here another two weights will be saved, that is the best weight will be saved, and another one is the last weight. Okay, and among them you try to go with this best weight will always give good accuracy. So in my case what I am doing is I am using that darknet. Okay, then I am calling detector. For testing I am calling test data. Under data obj underscore data, like previously I worked on folder called obj instead of custom underscore dataset. Then cfg, it's YOLO v4 obj cfg, and in backup I will be calling the best weight. Okay, once I call that, and here you need to feed the image. Here what image you need to feed is, here, come out of it. Yeah, under darknet you should upload some images. In my case I uploaded Steve Job image. Okay, this is 57353, and I uploaded Punit Rajkumar download.jpg. So here, okay, I will be running this part. Okay, first I'm uploading the image of Steve Jobs first. It will take some time. For first time it will take a bit more time to load that pre-trained model. A pre-trained weight here. Okay, once I run it, it will save image for me like this. Yeah, it says Steve with 99% accuracy. You'll do the same thing for Apu also. I'll let it load. First time it will take a bit more time. Yeah, if you get any errors or any problems while implementing this, let us know. Okay, we will help you without any fail. You can message us, or you can just visit our website also, that is Smart AI Technologies. Here we are providing IEEE projects for engineering MTech students, and some research projects will also be handled. We are working on PhDs. Okay, so we are handling all machine learning and data science, computer vision, NLP, and all those stuffs. Okay, you can see more here. Yes. So even we are trying to provide some data for free. In this case, crop prediction and advice alternative crop. If you say learn more, you'll see that here we are providing video itself, so it will be very helpful for you, I think. Yeah, here you can see for crop yield prediction and alternative crop advising using machine learning. Okay, this is part 2. Actually part 1 and part 2 is available in our YouTube. Okay, you can watch it, and anyway I will be providing you the link below. So here I am providing you almost all the information. which is very helpful for you. Okay, if you want any further help, let me know. This is taking a little bit more time. Okay, it's loaded. That's fine. Yeah. It says Steve with 99%. How we see it? Okay, it's unable to display it here. It is having some problem. Okay, so anyway, it saved that result here as prediction.jpg. So I will be displaying that image as prediction.jpg. Anyway, we done for Steve. Let us try it for Appu also. So we'll take a complete path of the image. Go laboratory and change the image. Now it will not take much more time to load. Okay. For first time it will take a little bit more time. Okay. Now it loads faster. Okay. So it says up with 99%. How we see it? So let us plot it using matplotlib. Now I think you can see up with 99% accuracy. Even we can do that by downloading any image from Chrome, say Steve Jobs. Go to images. Let us see how accurately our model is working. So let us go to Steve image and let us take this one of the iconic image. So let us download this image. Okay. Now I need to upload it to Google Drive. Where is that? Here it is. Rename it. Go here. This is the image name. What it says is syntax error. Okay, image name should be continuous. That is a problem. Okay, so now go to Google Drive, rename it. Here I will say Steve2.jpg. So now let us print it out. Yeah, you can see Steve is detected with 93% accuracy. If you follow the same steps which I followed, you will be getting good accuracy results for your project or for your internship, whatever it is. Okay, if you get any error, let me know. Okay, thank you for your time and patience. Thank you very much, and don't forget to subscribe and like our channel.